Good evening. This is another live training session from Unity Technologies. And tonight's session is going to be exploring the Blacksmith environment, which was a demo scene that came out after the Blacksmith short movie. So let's start with this, a little bit of fun. So this is what we're talking about. This is the Blacksmith environment. It is more of a game-related environment that was made with all of the assets that were used for making the Viking Village and Blacksmith demo projects. There are some things here that were custom for the Blacksmith, and the idea was that we'd package them up and give you all of the assets that were used in the Blacksmith demo and allow you to play with them, because the Blacksmith environment itself that was used for the mini-movie isn't really game-oriented. It works perfectly fine when it comes to making a little mini-movie. And I'll show you a quick picture in just a moment, but it has some problems when it comes to using it for people who are more interested in doing stuff on the game environment. Where can we find this? We can find this here on the asset store. I wouldn't download this now and try to follow along. This is a very, very large asset. It's 4.1 gigabytes. It is a lengthy import. And when it's importing and processing, Unity can actually become unresponsive. I just sort of give you a quick little warning there. So when you're importing it, don't be surprised. It's going to take a while to download. It's going to take a while to import. There's a lot of assets here, and there's a lot of high resolution assets here. And if during the import process, Unity spends so much time concentrating on doing the import that it shows up as unresponsive in your operating system, don't worry. Hold on. Just wait it out. It's just busy. Now, you don't need to do anything tonight. Sit back, get some popcorn, lean back and have a watch, because I'm going to guide you through this. A lot of talk about this particular asset package, and a lot of talk about how it was put together, and a lot of talk about lighting. And then once we get through that, maybe we'll go into some Q&A. And like I said, I've got 20, 30 pages of notes here, and it's going to prove longer than we can cover everything that's in this package. So I'm going to judiciously sort of skip over some things, and maybe we can come back to them later. So the first thing I want to talk about is the difference between the Blacksmith environment and what we have here for the package. So I'm going to zoom in here a little bit. And so this is the Blacksmith environment that we're dealing with today. And it's a small set of assets. As they said, we decided to rearrange the original exterior of the movie and make it more relevant to game production. If we come down on the page, and this is a blog post, which I'm going to copy and paste the link into there, you can see, if we look down here, this is the geometry and layout that they had for the mini movie, which starts in the smithy down here in the lower portion of the image, and then the blacksmith takes a cruise through here and comes out at the end. It is rendered in real time. It's high resolution. You can take a look at it. It's fantastic. But the original movie was designed, well, to be a movie. And we'll take a look at some movie sets, which I have some examples later on in this session, and look at the differences between making an open game world where you can sort of move anywhere you want to, and having a controlled world where you can choose which direction the camera can pan. And if you've ever played with this, if you get a chance to download it and take a look at it, you'll realize that when you're running the Blacksmith, you can pause the executable, you can scrub it back and forth, and you can move the camera a little bit. 5 degrees probably up, down, left, and right. But you really can't just stop and turn and pan around and look at the entire environment, because that's not really what it's meant for. And so as opposed to distributing the movie environment, which would be fantastic for a very, very small portion of our audience, which would be the people who were wanting to use Unity to make small mini movies, the majority of the people are making more traditional open game worlds, and this would be more of a frustrating environment or an exercise for them. So that's why we have made the package that we're taking a look at today. Yeah, this is a demo. And I think we should realize this going through the whole thing, that this is a demo. And this is a demo to show off certain assets and certain techniques. And it's not everything that will be perfect. Not everything that will be perfect for the movie. Certainly not, because it's meant more for a game. And it's not perfect for your game either. I mean, if you were to just try to make a game out of this particular demo and drop it onto, I don't know, some app store somewhere, and then try to call it your own, it probably wouldn't work very well as a game. But it does show off a whole bunch of game-centric techniques that will help all of us when we're making our game as we go forward. And then I'm going to do a quick play so we can just come drop in and see it. When we play it, it's got these the camera views that we saw in the demo. And then if you hit the C key, you're in a first-person controller. So we can look around, we can look at the environment. One of the things that is important to this is the scattering. The atmospheric scattering is very important. We'll talk about that more in detail a little bit later on, but the atmospheric scattering makes the lighting in this particular project work so well. And we can see all of the grass that we have. And I think we can't go off the edge in this one. We've got colliders that are going to prevent us from being able to go off too far off piece. So this is a bit of a bump and a hill. So this is the environment that we're working with. And I also want to say that this material that we're working on today is going to be more advanced. It's at least of intermediate difficulty, if not advanced difficulty. So if you're just getting started, definitely watch along. So if you're just getting started, definitely watch along, take a look, put it in the back of your brain. But this is something that is really more for people who've had some more experience with Unity. So what will we be doing today with all of this stuff? We're going to look at elements, just elements of the construction and lighting of this exterior scene. There is a mixed interior scene that's available. If you look down, we have, let me just go ahead and pause that. There is a Blacksmith interior, which is a mixed interior-exterior lighting so that you get some skybox. You also get some interior lighting stuff. We're not going to be looking at that today. We're going to be looking exclusively at the scene called Bridge Small 02. And also when we're looking at some of the solutions that we have here, that these are only, this is just one way to approach this problem. This is the solution that the folks at our marketing demo team did out in Stockholm. And these are the people that made the Blacksmith, that made Viking Village, and that made these assets. And you may find that there's a different approach that you prefer, but this one works, and this one works well, and there's a lot to be learned about it. What are we going to look at today? We're going to look at meshes. We're going to look at resolutions of those meshes. We'll look at the resolutions of those meshes. We'll talk about terrain, but there is no actual Unity terrain that's used in this project. We'll talk about some shaders, especially the blend, two texture blend shader that's used on the terrain that we have here. And we'll also talk about some of the sacrifices versus some of the advantages of the decisions that were made in this particular project. And so the main idea here is that you'll be able to download this, you'll get a jump start. This won't be a mystery to you when you get it off the asset store, and it'll give you a place to start working. So reading the questions people are asking, is this about gaming or is this about videoing? Well, this is about using a real-time render engine. Hopefully you will use this in either way that you want to, either if you want to use it for making short animated movies inside Unity, which is possible, as is shown by the Blacksmith movie, or for making your own games, because these do work. We're here in real time, you know, so if this was a game, this is what you'd see in your game. I mean, I'm running this real time right now. So it can work for both. It essentially, as real-time rendering, what depends what you want to do with it. I'm not telling you what you want to do with it, but this particular project is more game-centric than the way the assets were laid out for Blacksmith. So we want to talk about scene lighting as well. I want to talk about sunlight and skyboxes. I want to talk about materials and what to look out for. I want to talk about asset construction. I want to talk about light mapping UVs and maybe some detailed objects. And maybe a little bit about ambient light if we get a chance. I mean, we'll see how long we're willing to run. And I think that we should realize that ambient light in the current setup with Unity 5 is more than just simple flat light that we've seen in a lot of game engines and in previous versions of Unity. The ambient light that we use in Unity 5 is actually image-based lighting for our objects. And what are we not going to cover? We're not going to cover that interior-exterior scene. We're not going to cover the movie set for the Blacksmith. We probably won't get a chance to go into detail on the atmospheric scattering script, and we probably won't go into detail on the vegetation system and paint job and the grass shader that are used here, because we just don't have enough time. But I will give you links and show you places that you can continue your learning journey when you continue with this project. Now, one of the first things I think we should note is that when you're downloading it and when you're running it, let's go ahead and just get out. Thank you. Let's take a look at our build settings. And go to player settings, sorry. And we want this to be run in forward rendering path in the linear color space. So you might be able to move this to deferred, but there are virtually no lights in this. There's only the skylight. It's the only original light, one directional light for this entire scene. So there's no need for deferred lighting, and it definitely needs to be in linear color space. So if you find that you download the package and you import it and you take a look at it and it looks very, very funny, then you may be rendering it in the wrong path or in the wrong color space. So you want it in forward and you want it in linear. So the environment. Taking a look at this environment. Most of this environment was built in a standard 3D modeling package. So let's go to our scene view, and then let's just move out. Take a look at it from here. So we can see that we've got two distinct separate sets of meshes. We've got the high resolution mesh that's in the center, which includes where the village is, and then it's bedded into a much lower resolution background all the way around it. And then if we look at the detailed 3D models, these have all been created in a standard 3D modeling package. I believe it was done in Max. And let me go to Gizmos, and let's turn off light probe group and turn that off because we don't need to see those. So those that yellow triangle that we were looking at was the light probe group that goes and shows us where the light probes are that are working with our objects. And we don't need to see that, so I'm just going to Gizmos. And normally they're buried, but I've turned them on and off today, so it's up in the recently changed group. So these were modeled in a standard 3D modeling package, and they were saved as FBX files. The one big exception is that the background terrain was modeled using a world machine, and there's an extreme difference between this background and the background that was used in the movie. If we go ahead and look again at and we look at the movie scene, we can see that actually this was done in a lot more piecemeal kind of way. There was the water plane, and then all of the geometry that was used to make the mountainous backgrounds were separate pieces, actually of the same piece of geometry, just stretched and flipped and repositioned so that it's the same mountain peak used in a whole bunch of different positions. And it looks really, really great, especially once it was shaded. In our case, when we're dealing with the Blacksmith environment, this is one large world machine terrain that was exported out of world machine and then was used here in a background format. And the background geometry was the straight mesh out of world machine, and then it was decimated in ZBrush to reduce some of the poly count. There is no Unity terrain in this project. There's just a shaded low-res mesh for all of our backgrounds. And why did they choose this? A lot of people have asked, when I've discussed this before coming on, why have they chosen this background? And it's a quick solution to the issue. Had this been a proper game environment, this probably would have been a Unity terrain. And the advantage they had here was that it was a very speedy solution, as it's primarily just used for a backdrop. It's used for background. It looks really great. It's not actually a bad solution at all for someone in a game that has unwalkable terrain, so that if you get to this point where the extreme ends of your zone, they're unwalkable, you don't need a terrain asset. You can just use simple low-res geometry and a very simple shader. If you look carefully at the shader, it just simply, and we'll look at it in detail a little bit more, but if you look carefully at the shader itself, that's working with the background hills, it's just simply fading between two particular textures, which is the green and the rock. Now, what do you get when you make this kind of a decision? Well, the advantage, as I said, is a speedy solution to a primarily simple problem of having to need a background. You lose the ability to have your splat maps, the Unity splat maps, which you can have 4 textures that combine together. And we're just down to a simple shader, matte mix shader that will mix 2 particular textures. And you also don't get any tessellation. When you're dealing with Unity terrain, you get lots of detail up front and no detail far away. And this is fixed at low res. So if you're looking at this particular mesh, you're going to realize that it's fixed at this low resolution. And so the mountains in the distance are going to be the same resolution as the ground directly under the village itself, which may not be optimal for a game. Now, if you were to do this for a game, we probably would do it with Unity terrain. We do have a class on height maps. So let me just go ahead and bring that out. Put that link in the channel so that you guys have it. Introduction to height maps. And so this is a really good resource for how you want to be able to put together a terrain. If you wanted to bring in a height map from World Machine, you wanted to bring a splat map in from World Machine and apply it to your scene in Unity. So in the foreground, let's talk about the foreground. Foreground meshes. The foreground is also just a simple mesh, but if you look at the difference in resolution, seeing if we can get in there, let's look at wireframe. You can see the difference in the resolution between these two meshes. So that's a much higher resolution mesh that we have when we're dealing with the close-ups where we've got our vegetation, where we've got our characters walking. And again, in a real game, this most likely would have also been a hybrid of a terrain and geometry, where the base walkable surface, where all of the vegetation is, would be, let's close that down, would have been a terrain, and then all of the detailed objects, especially the concave material along the edge and the edge cliffs, would probably have been done as custom-made medium to high-res geometry as needed for your game. And both the foreground and the background use this shader, which we'll run into, which is called the Masky Mix shader, which is kind of cool when we get to it. Go back to the shaded view. So, shall we take a look at this Masky Mix shader just while we're here? If we, while we're talking about shaders, let's go ahead and take a look at it. Let's grab a piece of this cliff here to see if we can get close to it, get a good angle on it. So if we look, we've got terrain cliff, and we can see that it is made of tiled cliff, and the tiled cliff material is using something under Voland, which is the name of the blacksmith himself, and then standard Masky Mix scatter shader. And that's what they've used here to make this the details on this particular geometry. And what's interesting about this particular shader is that it's looking at the normals of the surface to go ahead and apply two different colors. So our primary color, the albedo, is just tiled cliff. And that's the rocky looking texture that we get for the base cliff. And then if we go back and we look on the Masky Mix additions, we have a moss, a simple moss texture that we have added on top of it. And then if we look at the details of it, let's just go ahead and drop that down, we can decide what the fall off is and what the threshold is for this particular amount of moss. So with this, so we can simply, with a rather simple shader that's included with this project, we can make something that has rock underneath and moss on top, and adjust the values that we have so that it looks as mossy or as rocky as we want it to be. And to sort of show this off a little bit more, I added in a little texture here. So let's duplicate this. And then let's just call this Snowy Cliffs. And let's make sure that we haven't, that we've done the right one. So tiled cliff, yeah, so there's a snowy cliff. And then I've got a snow texture here somewhere. And which one do we have? Snowy cliff's good. And so we can replace that with snowy cliff. And then we want to come back to our rock here. And then let's change that out. And then the one thing I need to change is that we're adding color to our come up. There we go. No, not that one. Bah, separate way. So now we have snow. And this is, again, where you can start to move around how much snow you want on your surface. You know, is it a heavy snowfall or a light snowfall? And then also we can use the world direction. So I'm just fussing around with stuff here. We can use the world direction to influence whether there is any wind or wind zones to it, because we can start to move this around so that it will all accumulate on one side of the rocks and not on the others, which would imply that there was wind that was blowing our snow around from one side to the other, so that we can accumulate all the snow there on that side and then have it blown off on this side. So interesting little shader that we have here. I'm going to go back and I'm going to replace, well, no, we can leave it out. One of the nice things also about this is that you can use and reuse your assets, because this will always end up with, say, the snow on top of the rock. There is a rock asset in here. So if I do a search for rock, oh, I'm looking at the wrong place. Not that one. This one, not snow, rock. So let's look for that rock asset, because I know there's one in here. There we go. Now this is going to be just a, I'm pulling this out. It's a submesh. Oops. Just closing some stuff down. It's a little submesh. Let's go ahead and drop that in. And then let's bring it out where we can see it. And so there's no material on it right now. So let's go ahead and take our snow. In the wrong one. Snowy cliffs. And so, oh, and there's no texture on that one yet either, is there? Snowy cliffs. So we've got the wrong texture on there, but that's good enough. And so as let's go back and we can rotate these. And we can see as we rotate them that again, the snow always ends up on top. And what this can allow us to do is also duplicate our assets. And then we can start to rotate them around to different places. And we'll still find that, again, the snow is on top on both of our rocks. And we're less likely to realize that we have duplicated that same asset and put it next to itself because we've reoriented it in a way that doesn't look like what we were expecting. I'm going to get rid of that. Undo those. I'll just get rid of it. Shift delete. Bye. Masking mix shader. Great for simple things like that. So you can mix your two textures together. So how is the scene lit? Now we've talked about sort of the base assets that we have. There's a little snow there. Let's go back and fix that. That was tiled cliffs, wasn't it? There we go. Pick something and zoom in. There we go. Back into the middle again. So how was this scene lit? Actually, before I get into that, I'll read chat. Mandy Saw asks, can Maxi Mix handle more than two textures? No, not as it's written, it handles two textures. It's a relatively simple shader. And again, as this is intermediate to advanced material, it gives people a very great base for being able to take that shader, and if they want to use it for something more than just using it directly, it'll give them a chance to sort of break that shader apart, have a look at how it's constructed, and perhaps maybe get additional layers to it. The big advantage of this particular one is it really is designed to sort of take rock or any sort of thing that you would have that would have something on top of it and add moss or add snow, and it's looking at the normals of the mesh, so it will stick that thing on the top so that'll give you exposed steep edges. Blacksmith link, someone was asking about where to download it. I wouldn't necessarily try to do this during class because it's going to take a while. As I said, it's 4 gigs, more than 4 gigs. So how is the scene lit? This scene was lit using a single directional light as sunlight and reflections from the skybox and bounce from the geometry. So very simple. There's only one light in this entire scene. And that one light is what's, let's back out a little bit. So that one light is the sun. That's lighting everything. And everything else is bounce and from image-based lighting from the skybox. So if we open rendering, take a look at what we're doing for rendering inside the scene. So there's two things that say rendering. There's rendering presets, which we'll get to in a second, and then just rendering. And so if you look at the scene, let me just move this down so we can do this in order. So there's a light probe group, which I want to turn back on temporarily. So there are light probes, and light probes are lighting a lot of the detail objects. I'll talk about that in a second, but there's a certain point where there's many small objects here that don't need to be light mapped. Small rocks, certain plants, they don't need detailed high-res light mapping. So they are going to be lit from this lattice of light probes. So these light probes are going to light characters, these light probes are going to light small detailed objects, and so there's a light probe group that's going to take the overall lighting, bake that lighting into the probes, and apply it to the objects that are between it. There is this thing called the Big Bad Sphere, Atmos Big Bad Sphere. And what this is used for the atmospheric scattering. And we're not going to go into a lot of detail, but if you suddenly wonder, what is this piece of geometry doing out here? It's for the atmospheric scattering. And then we've got a series of reflection probes throughout the project that can help us with reflections on our objects. So that's what we have inside rendering. And we'll find the light inside our rendering presets. And the reason for this, if we go ahead and we hit play, is if you can see that V to change the environment preset. So we can change to different times of day, and it's just a quick flick, and the entire scene sets up to a new lighting environment and a new skybox. Ooh, we may have monkeyed with something that shouldn't sparkle that way. I could have broken something when I was fussing around back then, because that's not supposed to sparkle that way. So that's why we've got these presets. And so each one of these presets has a directional light, an atmospheric scattering script, and then the camera with all of the camera effects. And we'll talk about some of those later on in this session. So I think it is important to know that this is lit with just the single directional light and the skybox. And that atmospheric scattering is a very, very important part of the scene. So if we were to turn off the atmospheric scattering, which we can find, we're in midday, atmospheric scattering, turn that off. It's relatively dull. And we can also see that, you know, the distance just goes and slowly fades off into fog. You know, it's not bad. We've seen games like this. We've seen very good and successful games like this. But if we have the atmospheric scattering script going, we can see that it gives much more detail. It doesn't fall off into linear fog or even logarithmic fog that way. It makes a difference which way we're facing. If we look up into the sky, we can also change some of these around. Let's take a look at some of the afternoon settings, like this one. And we can see that the area that's being lit by the sun looks very different, and the scattering looks very different from when we are looking down into towards the sun, because of the way that the atmospherics will affect that light. Now, when it comes to atmospheric scattering, we really don't have the time in this session to go through this in detail. But right now, oops, come back here. We have this blog post which discusses all of the details that we currently have on atmospheric scattering. And there is one scattering instance per setup. So one of the great effects of atmospheric scattering, if we look at the atmospheric scattering script, and like I said, we're not going to go into the details here because there's a lot of information and it's very fiddly, but when you get it dialed in right, it looks fantastic, is the fact that you can separate and divorce the visible skybox from the skybox that's making its contribution to the ambient light in the scene. So if we look at our lighting panel and we see that we have a skybox, so there's our skybox material, which is using Sunset C. So this is the skybox that is being used to help light the scene. This is the skybox that is being used for the ambient source, and it's being used for the reflection source, is 88 Sunset C, which if you look at that, let's bring up our preview window. Oh, sorry, we're not in the inspector. There we go. There we go, 88 Sunset C. Because the atmospheric scattering script, we have the skybox that we are seeing. What you can do with this is use one skybox that works better for your lighting, and then a different skybox that works best for what is visible. And why you'd want to do this is sometimes you could get too much of a contribution from the sun. So if you have a very bright sun, let's see if we can find one of these as a very bright sun. No. Bright sun. There we go. There's one with a bright sun. So if you have a skybox with a very, very bright sun, and then you also have a directional light, you can get into a situation where you end up having two contributions for the sun, and it makes it slightly more difficult to balance. And in the current setup in the lighting panel, the skybox that you see is the skybox that is also doing the contribution for the reflection and the contribution for the ambient lighting. And when you're using the atmospheric scattering script that is supplied in this package, you can change that so that you can perhaps go into Photoshop, you can fill in that sun with more sky, so it's the same color. It would be brighter in that general direction, but you don't need that absolute high hotspot on an HDR skybox. And then you can show a slightly different skybox in your atmospheric scattering so that you have one that's visible and you have one that's contributing to the lighting that you have in your game. And why is this important? Well, it's because balancing the direct light and the ambient light is one of the primary issues for getting good lighting in a scene. And the more control that you can give yourself and your designers over that balance, the more likely you're going to have some good lighting. You'll have good lighting and better balanced lighting. Now, where does this all start, our lighting? The base starts in good, properly created, well-balanced materials. You don't want, especially things that are too dark, you don't want materials that are too dark, certainly not in the original textures. So when you're dealing with, you know, an item, turn those back on, turn off, gizmos. Let's get in there. Don't know if this is really the most perfect example, but when you're dealing with, hold on 2 seconds. And yes, you can pop out the preview window when you right-click on the header bar. When you want to make your original textures, you definitely do not want to make them too dark. You don't want them too light either. You want them good range for visible colors. You want to be able to express the original intent of the material itself, starting with your texture, so that you don't have too much shadow in it. You don't have too much of that detail that you want to come from your environment, because you can get into this point where you start to bite your own tail, where if your materials start becoming too dark, then you might want to boost your lighting, which might then throw off the way that the lighting works, may force you to make more bad materials or make more bad textures to make up for the fact that your original materials and original textures weren't good. So start off with textures that are not too dark, have good detail and are well balanced, and have a good range of visible color and good visible values. Let me go ahead and close that down. And then with our lights, with our directional lights, they should be balanced to work at around 1, with an intensity of 1. So if we take a look at our directional lights, they are not that far out of the range of 1. If the lighting and your scenes start to look good and the values are either above 2 or below, you can go a little bit below 1, but 0.75, you know, for a generally properly lit scene, then there's probably an issue with your materials. And like I said, there is this dangerous spiral that you can get into where you can have bad assets that lead to bad lighting, and then bad lighting leads to balancing more bad assets. If you find that you need to darken your textures, you should not darken your textures in the artwork, but we should be doing that inside the material. So if we take a look at a series of materials, and what we're going to look at here is the materials here and what's going on here in the albedo color, we can see that some of these are darker than full brightness, because if we look at this texture, come up here, this texture is relatively bright. And let's go back to our materials. Where are our materials again? The ones we're looking at. So here's the gate. It's been darkened by changing the albedo color. So here, if you go through it, you can notice that we're mostly white, but if we want to change something, we're changing that albedo color tint, which is up here. If you need to make adjustments to the textures, keep them bright, keep them clean, make those adjustments in the albedo color setup in your material, and then you have a properly balanced material. Now, the lighting in this demo is roughly around 1.5 on all of the directional lights. So if we were to crack these all open and take a look at the directional lights, we're going to see that they have 1.7, 1.45, 1.5. So most of these are about with an intensity of about 1, with the exception of no sun, you know, and some of these that are special. And it's worth remembering that with a light, color is going to reduce intensity, and cookies, like if you have clouds or that sort of thing that end up being in front of the light, will also reduce intensity. So the usual range is between 1 and less than 2 as a good target. So now, assuming that we have good materials and we have good balanced light, now what? So I think it's also important to remember that this is not a science. It's an art. And so we have these numbers that give us some sense of when we're completely out of the ballpark, when we're off-piste. As Zach Attack says and concurs that, if you're down below 0.75, you're up above very much higher than 1.5, then you may be out of the range and you may end up in this problem where you're trying to balance your materials. It's like trying to solve an equation with too many variables. You get stuck trying to balance all of this. And so it's still an art. We want to make things look good, but there's still some good parameters to stay inside. So when we're lighting our scene, our detailed objects, our small objects like rocks and ferns, small details that are scattered around the landscape, we don't want to bake these in the lighting window. Lighting window over here, lighting panel. We want to use light probes for these small objects. So what we want to do is make them not light map static. So they aren't static. They aren't going to be part of the light map. They're not going to be light map static. These small objects are going to be lit by the light probes. So they're going to make sure that we use light probes for them, and the light probes will be lighting them, and they won't be baked, because otherwise you'll have some insane bake times, because it's going to try to bake maps for all of those surfaces. So definitely use those light probes for those small objects. The settings for this project are pretty much default. There are some points where I've experimented with upping some of the bounce intensity, and you can get some good looking effects depending upon style by increasing your bounce a little bit, maybe 1.5 at the most, and you can get some interesting looks out of that. But in general, I discovered that this scene bakes perfectly fine at the default settings. And you want to make sure you know what you're baking, because if you try to bake too many things, it's just going to take a long time. The other thing is your baking resolution. Now, this completely depends upon the object and how it features in your scene. So let's just take a look at light map resolution in this particular scene. And I think if we go to UV charts and then show light map resolution, I'm not sure whether, yeah, we haven't started baking it, so it needs to have a quick look at it. And we can see the resolution of the background is massive, really big pixel count. They're very wide, huge. You move into the village itself, and rocks, and the terrain, again, very large. You get soft feeling under here. Soft feeling around here. You can see that this has got some bounce coming up off the ground a little bit. And then you start to move into man-made structures, things that need more detail that we can see. Let me just frame select it on that. So we can see that the resolution starts to increase. The other place that you can set, so you can set your resolution, is in the scene lighting itself, which is your baked resolution, which is your texels per unit. And let me talk about how you get your resolution. So your resolution, you can set it in a couple of places. You can set it in the baked GI, where you can set your resolutions of texels per unit. You can also set it on a per object basis, which is, you can talk about scale in light map for the particular things that you're dealing with. This is a little magical. Most of the things, if you look through this particular project, are going to be scale in light map of 1, which just means that they've been set up outside of Unity. And there are many factors that will influence the light map resolution of an object that you bring in. And the UV unwrap, how the object has been unwrapped in the original package, the physical size of the object in the scene, and then the settings in the lighting panel, which you can do per object, per scene, which we've talked about. So you can set up your UVs for your model, and that will influence the way that the UVs are working inside the Unity scene. And when you're starting to bake, you want to bake in very broad strokes. You want to start with very low res and then start to push these up until they start to look good. So you want to start baking, you want to bake down and dirty, and you want to bake fast. You want to make sure that you have no small objects that are being baked. You want to make sure that your resolutions are very low for all of your objects, and then do a bake and find out what doesn't work. What you'll probably discover is that your outside terrain is going to work fine, and that some things inside the, the detail of your, in this case, the village, are going to need higher resolutions. And so you keep incrementing it as you go through and as you solve your lighting problems, keep pushing your resolution up, and then get it to the point where you're finding the detail. And you don't have to have the longest bake times. It's not something where you sort of go the other way, where you start with everything at super high and then you sort of try to bring it down until it breaks. Start the other way. Start wide, because this can be a long process if you get it wrong. If bake times start to immediately skyrocket, then you should start to investigate and figure out what it is that has been set up wrong, because this was benchmarked on sort of a mid-range laptop and baked in under half an hour, and it bakes on my machine much, much, much faster than that. So if it's been set up properly, you shouldn't get insane bake times. Now, a little note about ambient occlusion, especially when baking. Don't need you. Thank you. So we're looking at the bridge here, the details of this bridge. And most, if not all, of the objects in this scene have an ambient occlusion pass that has been baked in from the original 3D modeling program. And ambient occlusion can do a couple of things. First of all, it gives it a level of shadow detail or shadow-like detail that can be much finer in detail than the baked lighting is ever going to be. So you've got your broad strokes from your GI working in the scene, even if you have real-time GI, and then you have this sense of fine detail that comes from the model itself. On top of that, with the standard shader, the ambient occlusion, that occlusion pass that you get in the standard shader, let's see if we can bring that back. Scene. Bridge main. Look, there we go. So this occlusion pass will also prevent specular reflections in parts of the model that wouldn't normally be reflective or shouldn't be reflective. You can get, if you end up removing the ambient occlusion, not only does it look much more dull, so there it is with the ambient occlusion, and that is it with it removed. I don't know if this is the perfect example. It's not very shiny. Let's see if I can find some place that's a little bit more shiny. Find a spot that would normally not get some light. Let's try under there. Let's see if we can see it. Oops. It's going to be hard to see, but you can get things like underneath this lip. Let's see if we can jump up the specular on that. No, that's not going to work. I'm just trying to see if we can see underneath it and see a point where, but you can get these points where you're suddenly seeing reflections and grazing angle glossiness off of items where the sunlight or the direct light shouldn't actually ever hit. And that's just because of the way that the shader is looking at the angle of the camera, and the shader is looking at the angle of the texture and where the light is. And so this additional layer of the occlusion pass also gives the shader additional information to tell it where light wouldn't normally reach. So having an occlusion pass, a baked occlusion pass that you include inside your standard shader, can also help a lot. Charts and UVs. Just a quick note on charts and UVs. But I'm going to wrap it up relatively soon, and then I can give you some additional things that you can look at for reading resources to follow on this. A note on charts and UVs that the textures use a UV channel of 0, or just UV, the first UV channel. There is a slight discrepancy between the 4 UV channel names that meshes use and the 4 UV channels that shaders use, which, if I remember correctly, the 4 UV channels that meshes use are UV, UV2, UV3, and UV4. It's not 0-based. The channels used in shaders are UV0, UV1, UV2, and UV3. So just be aware of that in case you get a little bit confused. I certainly do sometimes. So the textures are going to use that first UV channel 0 when it comes to shaders. And the light mapping is going to be using UV channel 1. Now, Enlighten uses UV channel 1 as guide, and it will adjust these UVs as needed a little bit to chart and cluster these UVs for best performance. So if there are any times that you have something and you know that the light map UVs that you have created are good, and you're finding that it goes into the lighting system and it gets changed in a way that you find suboptimal, it's probably better for performance but doesn't look good, there is a preserve UVs button on the object in the lighting panel. So if you look at the object, you can actually preserve the UVs and not have it change it when it's going through its charting and clustering. Now, also along those lines is that Enlighten will fall back to the UVs on UV0, which is your texture UVs, if there is no UV1. But Enlighten is definitely going to end up repacking these UV charts so they don't overlap. And there will be more situations where this is suboptimal. So as a general rule, you should use either, when you're importing your object, you should use create light map UVs. See if I can find a model in all of this. Oh, not textures. Terrain vegetation. Well, let's do it this way. What do we got? We have the mesh. So we can generate light map UVs. So if you have not created your light map UVs, you should probably have Unity generate them for you so you're not falling back onto your texture UVs. And lastly, welded vertices. When you're doing your light mapping, to work well with meshes, they really need to be what are called watertight meshes with welded vertices, especially along joints where the walls and the ceiling and the floor come together. Because it's very common when you're looking at something that has trying to see if we can find a house that has one. When you're looking at things where they join up, they're not really having an interior setup, but it's very rare that you're going to find the edge of a texel is going to be exactly along the edge seam of the geometry. And so when it's being mapped and there aren't welded seams there, there is a good chance that the texels will start to bleed on top of each other. So it's good when you're building your models to make sure that you have watertight models with welded vertices. And this is especially true because of the partial texel issue. Last subject, tone mapping. I want to talk briefly about tone mapping. What is tone mapping? I'm in the grass. That's not very helpful. Okay, let's have something that's pretty. Let's find a nice shot. Something like that. Tone mapping kind of ties all of this stuff together. High contrast environments can never really be real, especially in a video game, as our eyes, when we're looking at stuff, will correct for the darkest darks and the brightest brights. And there's kind of two solutions to this. There is adaptive exposure, and then there is compressed high dynamic range. Now, compressed high dynamic range can look strange because there ends up being sort of no blacks and no whites. And I have, some examples of that. I mean, looking at Wikipedia and talking about high dynamic range, the idea is that you're taking, something that's really dark and something that's really bright, and you kind of jam it together, and you can see a whole sorts of stuff. You can see all into the darkest darks, and you can see into the brightest brights, and it's very similar to what your eye does when scanning around. But sometimes it isn't really what you expect, because there are times when you really want things that are dark or are bright. And compressed high dynamic range, where you're trying to shove it all into the ability of your renderer to be able to show that, may not look right. But adaptive exposure also has some other problems too, which is you can have adaptive exposure in your tone mapping. It can be better, but it has to be tuned correctly, because if not, it can look a lot like bad auto exposure on a cheap camcorder, if you know what I mean, where you suddenly point at the sun and everything goes black, and then you point down at the ground and everything blows out. There are problems with adaptive tone mapping that if you use, can be really, really good to solve this problem, but you have to make sure you tune your automatic tone mapping correctly. So let's look briefly at the tone mapping that we have. Okay, let's go up here. All sorts of, nope, don't want to do that. All sorts of rubbish open. Let's close this down. So I'm going to look at the first-person controller, which has a camera, and the camera has this tone mapping. And this tone mapping is a logarithmic tone mapping script that will help us bring together all of our lighting. And essentially, if our lighting is balanced, within a certain range, we want to do all of our fine-tuning inside our tone mapping script. Actually, let me show you that with the midday one that we've got going on. This is going to be on the camera as well. Go into game view. So without tone mapping, we see just a slight change in the color and a slight change in some of the densities. And it's remapping the image that we're seeing, and it's using a lookup table. And this one says it's based on Kodak D60 with a black fix. And so when you're dealing with just turning it on and off, this will allow you to come in and do some of the subtle, we're going to ignore the adaptive part of this, but it will allow you to do some subtle balancing, because you could get stuck when you say, oh, this part's a little bit too yellow and that part's a little bit too orange. You can start there and you could mess with your lights a lot, or you can get your lights in a good range, bake what you need to bake, and then do your final level of color correction using the tone mapping script. And it's a little bit like when you get into film post-production, doing your post-production live on the camera. So let's take a look at what this does when we're inside our first-person controller, which I'm going to leave open, and we hit play. And then go down to our character. And so when we're looking around, we don't see too much of a change. And it looks good. It's relatively well balanced wherever I point my camera. But that's partly because this particular instance is it's well balanced. Let's come over here where it's particularly dark and then start monkeying with stuff. Now, first-person camera. We've got enable adaptive going on. Let's change the adaptive max to something ridiculous, and min to something ridiculous as well. And now you can see as we look around, so we can show a good version of that, the speed, and let's just change this down to even slower so we can see the lighting change. So when we're looking at, look at on the left-hand side of because my mouse is working, sorry, I can't point it up. On the left-hand side of the screen, we've got this bit of stone, and it's relatively dark, and then we come down into the dark area, and it brightens up, a little bit like the way our eyes would. But now I've slowed it down, so it becomes very obvious, and I've made the extreme range very huge. So this type of tone mapping can actually be very useful, when you do stuff, but you can see if you don't balance it right, you get this funny feeling when you're moving around. So the defaults in this work pretty well. With your particular game, you might want to do something different, but definitely when you're finishing everything up and you're doing your final color correction, take a look at the tone mapping script, take a look at the adaptive tone mapping script, take a look at what you can do to sort of tie all of this stuff together. When I've talked about this with other people, there has been some question as to why it needs to be done. And so, briefly, I wanted to talk about lighting a movie versus lighting a game. When we light movies, we throw in huge amounts of fake lighting, and we change our exposure, we change our lighting, we change tons of things that you can't do in a video game very easily. And so when you're doing things in the video game, you have to find a way that this works no matter where you're facing the camera. The player can move their camera around anywhere they want to. They can face it in any direction they want to. You can't do a fill, a rim, and a backlight and a key light. It's just not possible. And when doing our balancing and doing our color correction, we have to find subtle and elegant ways of doing it, but doing it on the fly while our game is running. Hopefully that's a quick overview. There's a lot more to be said about this package. The guys in Stockholm have put a ton of stuff together in here. We haven't touched on the grass and vegetation system. We haven't touched really on the atmospheric scattering system. I've given you links to the atmospheric scattering system. So I've given you height maps, atmospheric scattering. There is a thread on the forum that you can talk to us about it. So there's the thread on the forum in teaching. And definitely the introduction to a lighting and rendering in Unity. We've put that together this year, and it's quite comprehensive, and it's very important when you get to this level of working with Unity. And then lastly, let's grab it off the asset store. So, Q&A. Havitalio says, so 2 textures equals 1 shader, 2 shaders maximum into 1 material. No, it's 1 shader per material, but you can have multiple materials applied to different sub-meshes. So depending upon how you break apart your UVs and your sub-meshes in your model, you can apply different materials onto different parts of it. And the number of textures that go into a material depends entirely upon the shader, because the shader is going to have a slot for different materials. So this shader, the cube map shader, will only take a cube map. We have a bunch to choose from, but it will only take a cube map. Ocean is a standard specular shader and can take all sorts of textures. Snowy Cliffs, that's the masky mix. Then there are a series of textures, including the one that you're mixing it with, and then the main one. But the main one, as we can see, has an albedo, specular, normal, height, occlusion, emission, and detail mask, and the secondary mask of the standard shader. Pandaman 3D says, can you recommend a good tutorial for using light probes? They're relatively straightforward. I would suggest simply looking at the documentation. So let's get rid of some of these useless bits here. Go to Unity documentation manual. And then we are looking for Ligahit probes. Oh, there we go. I mean, this is relatively good explanation for how they work and what you need to do. All in Lab says, would the shader we saw, the snow one, work with Unity terrain? No, probably not. But to be honest, if you were making a terrain in something like World Machine could supply you a splat map. The big advantage of that particular map is for doing stuff like laying down rocks or things that change. And so what I would do would be make my terrain in World Machine. I would lay out my splat maps there. I'd lay out my snow in World Machine. I'd bring that in and take a look at the link on using height maps. And then for things like boulders and mid-sized detailed objects, I mean large but still detailed objects, I would use that shader and it would just be a rock with snow on it. And then I could mix and match my rocks a bunch and it'd be harder to tell. Picture Me Rolling is saying, in the end, the terrain is also just vertices with normal, so it probably could work. It's worth trying. I'm not sure how integrated the system is, the Unity terrain system is, for when you try to give it some new shaders, because you can put because you put the textures and the normal maps for the textures into the terrain system, and then you build the splat map inside the terrain system, but there may be a way that you can hack it. Not sure. Pandaman 3D says, To understand this better, I had a scene take over a day to bake my lights. Is that due to scale or unregulated textile usage? All of my meshes had generated UVs from Unity. It could be just too much material. The other thing that it could be is usually when I see super long bake times, it's textile density that's too high. People trying to bake what I call detail objects, sticks, stones, skulls, small plants, and anything that essentially doesn't move, they nail it down, call it light map static, and try to bake it. And then often if you imagine a small stick on the ground, I don't know if we have any small sticks on the ground. I'm trying to think of something small other than these plants, or we could imagine something small. These are all put together as a... What am I looking for? I want that mesh. Yee. And then let's just give it some silly, useless material. Barrels look good. So it's not pink. And then let's scale this down. Oh, it's not what I wanted to scale down. I want my stick. We now have a stick. Look at that. It's a stick. What's brown and sticky? Stick. So you can imagine, this is a long way to say, we have a stick. And that stick chart. Let's make it lightmap static as well. Stick, static. Lighting. Stick. You know, it's not a very big light map, but still, you know, here's some texels. You can see them along the side. Now, if you have a whole bunch of these, you know, it's going to take, you know, a bunch. You don't want to bake that. So you don't want these light map static. You want to make these objects lit by the environment. The best thing to do with that is to use light probes for that. The other thing is starting off very wide, you know, where you start off with some very, very low resolution bakes and then see and slowly push them up. We could start to break apart your particular job, Pandaman 3D, but I would definitely start with wide, very low textile use, and then slowly get it to work. And remember the ambient occlusion that can help you with certain models as well. Kastrakan asks, speaking of 2D, can the mixed texture shader work on sprites? You can give it a try. As long as they've got normals, it should work. But I haven't tried it. Matt GC1 says, I have a pretty decent computer. I've made a small town with many street lamps, and it only runs at 30 frames per second. How do I increase that? There are many things other than the lights that could be slowing it down. The first thing I would check is to make sure that you are in deferred mode. The more lights that you have, edit, project settings, player, and then into deferred mode. For this particular job, we're in forward, because forward, it costs more per light. But you get some other advantages out of forward. I don't want to go into the rendering paths today. But in general, if you want, let's give it something nice to look at. In general, if you have lots and lots and lots and lots of lights, you want to go into deferred mode. And you can look up these two rendering paths in the documentation, the forward versus deferred. So that would be the first thing I'd check to make sure that you're in deferred mode so that all of those lights aren't costing you a ton. And then I would run into profiling and start to profile your game and see if it really is the lights that are causing the slowdown. Because my feeling is even if you've got a ton of lights and you're in deferred mode, you shouldn't be being slowed by your lighting. Devonio says, I have a day-night cycle with different sun and moon light colors in the animation. Will the pre-computed real-time lighting update accordingly? Yes, that is what it's meant for. You need to do the pre-compute, and then you should be able to update that with real-time global illumination. Alan Matano asks, when working with textures, do I have to make a level correction of, for example, 1.5 to the photos in Photoshop to make them lighter, or just default photos are okay? Or is there a value that works well, like, for example, gamma to linear value? In general, you shouldn't have to make any particular correction when creating your lighting. I would definitely look at that link I said to lighting and rendering, because there's some stuff in there that might be able to be helpful. But clear, straightforward, remove as many shadows as possible. One of the best things to do is to try to remove that type of detail and get down to what the base material is, and then leave things like the shadowing to the normal map, to the ambient occlusion map, and additional parts of the shader. So you're trying to create the sort of the simplest, straightforward, most unlit texture. Because in the past, a lot of times people were putting that type of lighting into sort of pre-lighting their textures and materials. And now, in this case, you do not want to have any sort of pre-lighting at all. You just want to have the most simple base texture that you can, and make it just as bright as possible with a full range of information. And if you do need to reduce that amount of information, or at least that brightness, you can do it in the material using the material's color. I guess I'm not suggesting that you try to counterbalance by making something twice as bright so that you can bring it down in the scene. You should be able to go in and not make any changes at all. But if you were to err on the side of being brighter and not being worried about trying to put in that sort of shadowing and texturing into the material itself. Cool. All right. I'm going to go. I'm going to sign off. Thank you very much for coming. Deeply appreciate all of your attendance. And you can follow us. You can follow us on Twitter. I am at The Ant Ranch, and then at Will Goldstone, at Matt Mirrorfish, and at Mike Geig. So thank you very much, and I'll see you in a couple of weeks.